The dawn broke over the sprawling Japanese airbase with an uncharacteristic stillness, the kind that precedes moments of profound revelation. The morning light cast long shadows across the meticulously maintained runways, where a gathering of engineers, military officials, and intelligence analysts assembled with a mixture of anticipation and guarded confidence. The air was heavy with a tension born not from immediate threat, but from the promise of witnessing a technological marvel that might redefine the balance of power in the skies above the Pacific. At the heart of this anticipation stood the P-51 Mustang, the latest iteration of American fighter innovation, shrouded in both admiration and skepticism within the Japanese defense community. For decades, Japan's air defense posture had been built upon a foundation of advanced stealth fighters and sophisticated radar networks, designed to detect and deter any aerial incursion well before it threatened the homeland. Confidence in this system was deeply ingrained among Japanese air commanders, who relied heavily on the combination of cutting-edge technology and rigorous doctrine emphasizing rapid interception within a clearly defined perimeter. The Mitsubishi F-3 stealth fighter, recently inducted into active service, symbolized the pinnacle of this approach, an aircraft optimized for low observability and precision strike within regional airspace. Yet, as the Mustang's sleek fuselage gleamed under the rising sun, Japanese observers could not help but note the subtle differences that set this American fighter apart from any previous generation. The aircraft's design combined aerodynamic refinement with an unmistakable aura of capability that transcended conventional expectations. Though outwardly reminiscent of classic fighter silhouettes, the Mustang carried within it a cluster of innovations that American engineers had painstakingly integrated, promising a leap forward in operational performance. Whispers circulated among the gathered experts: was this merely incremental improvement, or did the Mustang represent a fundamental shift in aerial combat potential? As the Mustang's engines roared to life and it taxied toward the runway, the atmosphere grew palpably charged. The pilot, a seasoned veteran well-versed in the nuances of high-performance flight, executed a series of pre-flight maneuvers that underscored the aircraft's agility and responsiveness. Japanese engineers scrutinized every detail: the contours of the airframe, the configuration of the control surfaces, and the subtle vibrations transmitted through the cockpit. This was not a simple demonstration, it was a calculated unveiling of the Mustang's capabilities, intended to impress and perhaps unsettle the observers who had come prepared to measure it against established benchmarks. At the command center, senior officers monitored telemetry feeds and sensor data relayed from the Mustang as it ascended into the stratosphere. The aircraft's sophisticated avionics suite, a product of integrated sensor fusion, provided real-time situational awareness that seemed to extend beyond the horizon. Japanese radar operators noted the jet's trajectory with a mixture of professional curiosity and unease, as the Mustang demonstrated flight endurance and speed metrics that hinted at a broader operational scope than previously anticipated. These preliminary observations planted a seed of doubt regarding the robustness of Japan's air defense perimeter. Could this aircraft operate effectively at distances that outstripped existing interception capabilities? In the quiet rooms where strategic assessments were routinely crafted, the implications began to take shape. The Mustang's extended operational profile suggested a capacity for missions far beyond simple air superiority within contested zones. It hinted at the ability to conduct long-range escort, deep reconnaissance, and persistent patrols, all while maintaining a high level of combat readiness. For the Japanese command structure, which had long relied on layered defenses and rapid response tactics, this presented a daunting challenge. The assumption that any hostile aircraft would be detected and engaged within a tightly confined airspace was now subject to serious reconsideration. Simultaneously, the psychological dimension of this encounter became apparent. Among the assembled pilots and technicians, there was an undercurrent of respect tinged with apprehension. The Mustang was not merely an adversary aircraft, it was a symbol of American ingenuity and determination to push beyond established limits. This realization resonated deeply within the ranks, as it suggested that the technological race in aerospace warfare was entering a new phase, one where endurance and flexibility could eclipse raw speed or stealth alone. The Japanese air commanders were confronted with the necessity to recalibrate their strategic vision in light of this emerging reality. Outside the confines of the command centers, the airbase itself reflected the broader strategic posture of Japan's aerial forces. Hangars housed an array of aircraft optimized for rapid deployment within regional theaters, supported by extensive ground-based radar networks and missile batteries designed to create an impenetrable shield. Yet, beneath this confidence lay an unspoken vulnerability exposed by the Mustang's presence. The extended range capability of the American fighter challenged the very concept of a fixed defense perimeter, suggesting that future conflicts might be fought across far greater distances and with a fluidity that defied traditional containment strategies. The engineers who had devoted countless hours to the development of Japan's stealth fighters found themselves grappling with a new benchmark. The Mustang's design, integrating lightweight composite materials with cutting-edge propulsion innovations, demonstrated that endurance could be achieved without sacrificing maneuverability or firepower. This revelation prompted intense technical discussions, as experts sought to understand the precise mechanisms enabling such performance. The hybrid propulsion system, coupled with advanced fuel management protocols, appeared to grant the Mustang an unprecedented operational radius, enabling it to sustain prolonged sorties and strike missions deep within contested airspace. As the morning progressed, the Mustang completed a series of flight demonstrations that showcased its versatility and resilience. It executed complex aerial maneuvers with a grace that belied its robust airframe, maintaining high speeds at altitudes that strained the limits of conventional fighters. Japanese test pilots and observers exchanged measured glances, recognizing that the Mustang's capabilities represented a paradigm shift. This was not simply an evolution of existing technology but a strategic leap that could redefine aerial engagements in the Indo-Pacific theater. The implications for Japan's defense strategy were immediate and profound. The traditional model, predicated on early detection and rapid interception within a defined perimeter, now seemed insufficient. The Mustang's extended range capability allowed it to operate well beyond the reach of current radar nets and missile systems, effectively eroding the buffer zones that had provided Japan with a sense of security. This realization compelled Japanese air commanders to initiate urgent dialogues about enhancing sensor networks, extending aerial refueling capabilities, and developing countermeasures capable of neutralizing the Mustang's advantages. Within the higher echelons of Japan's military leadership, the Mustang's arrival prompted a re-evaluation of long-standing assumptions. The airbase, once a bastion of assured superiority, became a crucible for strategic innovation and adaptation. The Mustang was not merely an aircraft, it was a harbinger of a new era in aerial warfare, demanding a recalibration of tactics, technologies, and doctrines. The morning's quiet anticipation had given way to a sober acknowledgement of the challenges ahead, an acknowledgement that would shape the trajectory of Japan's air defense posture in the years to come. As the initial demonstration of the P-51 Mustang concluded, Japanese analysts and military officials retreated to their respective command centers, compelled to scrutinize the data with a newfound urgency. The air was thick with a palpable tension, each report confirming what had already begun to unsettle the collective confidence. The Mustang's operational range far exceeded all prior assessments and official specifications. This revelation was not merely a technical curiosity but a strategic upheaval that threatened to unravel the carefully constructed tapestry of Japan's air defense perimeter. The detailed telemetry painted a picture of an aircraft capable of sustained flight over vast distances without compromising speed or combat readiness. Unlike previous generations of fighters, which necessitated frequent returns to base or reliance on precarious in-flight refueling windows, the Mustang exhibited an endurance that seemed almost boundless. Its fuel efficiency, combined with hybrid propulsion innovations, allowed it to patrol and strike deep into contested zones, effectively extending American aerial reach well beyond established limits. For Japanese air commanders, this defied the fundamental premise upon which their interception strategies had been based. Within the echoing halls of the airbase's intelligence rooms, teams of specialists pored over flight path reconstructions and sensor logs. The Mustang had not simply matched endurance expectations, it had shattered them. Official documents, once considered definitive, were now rendered obsolete in the face of empirical evidence. The extended range capability of the Mustang meant that it could operate from bases hundreds of kilometers from the front lines, maintaining a persistent presence that Japanese radar and interceptor networks were ill-prepared to counter. The operational radius was no longer a constraint but a tactical advantage, enabling the Mustang to outmaneuver and outlast any adversary within the theater. The psychological impact of this discovery rippled through the ranks. Officers who had long relied on the predictability of their defense grid found themselves grappling with a stark uncertainty. The assumption that enemy aircraft would be detected and engaged within a relatively narrow airspace was now open to question. If the Mustang could patrol beyond radar horizons, strike with impunity, and return without exhausting its fuel reserves, then Japan's existing early warning systems and rapid response protocols faced critical vulnerabilities. The extended range capability redefined the very geography of threat and defense. Japanese radar operators reported intermittent detection of the Mustang at distances previously deemed implausible for sustained engagement. This intermittent contact underscored the challenge. The aircraft's endurance allowed it to exploit blind spots and gaps within the radar coverage, slipping through defensive layers with calculated precision. The Mustang's avionics suite, optimized for long-range situational awareness, further compounded this problem by enabling pilots to anticipate and evade interception attempts. The Zero fighter, once the feared dominator of Pacific skies, now appeared limited in both endurance and tactical flexibility when contrasted with this new American intruder. Strategic discussions among Japanese air commanders grew increasingly intense. The extended range capability of the Mustang forced a re-examination of operational doctrines that had remained largely unchanged for years. The notion of a fixed air defense perimeter, guarded by stealth fighters like the Mitsubishi F-3 and backed by missile batteries, was being challenged by an adversary capable of operating fluidly across a much broader expanse. This capability threatened to render static defensive measures obsolete, demanding a shift toward more dynamic and far-reaching engagement strategies. At the heart of these deliberations lay a profound tactical dilemma. The Mustang's endurance meant that Japanese interceptors, even when scrambled promptly, might be unable to engage before the American fighter completed its mission and withdrew. Extended patrols permitted by the Mustang's fuel efficiency enabled it to loiter over strategic targets, conduct reconnaissance, or deliver precision strikes with impunity. The Zero fighter's famed aerial maneuverability, while still formidable in close combat, was undermined by its comparatively limited range and fuel capacity. The extended range capability effectively shifted the contest from dogfights within visual range to a broader battle of attrition and reach. Technicians and engineers at the airbase intensified efforts to analyze the Mustang's fuel management systems and propulsion technology. The hybrid power plant, combining traditional turbine engines with advanced electric thrust augmentation, allowed for optimized fuel consumption across different flight regimes. This innovation extended the operational envelope without sacrificing speed or climb rate. Furthermore, the Mustang's airframe incorporated lightweight composite materials, reducing drag and structural weight, thereby enhancing endurance. These technical breakthroughs were not mere incremental improvements but represented a fundamental reimagining of fighter design philosophy. This extended range was further amplified by enhanced in-flight refueling capabilities. Unlike Japan's current fleet, which relied on limited tanker support with constrained operational reach, the Mustang's integration with state-of-the-art aerial refueling systems permitted sustained sorties far beyond the confines of friendly airspace. This logistical advantage magnified the strategic challenge, as it effectively allowed American air operations to project power deep into contested regions without the necessity for forward bases, a capability that Japanese planners had not fully anticipated. The operational ramifications of these findings extended beyond mere technical considerations. The Mustang's endurance redefined the parameters of aerial engagement, compelling Japanese commanders to anticipate a new class of threats that could strike with little warning and evade countermeasures through superior range and persistence. The traditional emphasis on stealth and rapid interception required augmentation with expanded radar coverage, improved sensor fusion, and more flexible deployment of aerial assets. This realization catalyzed a strategic pivot within Japan's air defense establishment, prioritizing adaptability and extended reach. Japanese pilots, who had trained extensively to exploit the Zero fighter's agility and close-range dogfighting prowess, now confronted a sobering reality. The Mustang's ability to remain airborne for extended periods without degradation in performance meant that engagements would increasingly hinge on endurance and situational awareness rather than pure aerial maneuverability. This shift demanded new combat tactics, emphasizing energy management, long-distance tracking, and coordinated multi-aircraft operations to counter the Mustang's persistent presence. The broader strategic calculations also shifted in response to the Mustang's capabilities. Japan's air defense perimeter, previously considered a reliable barrier against hostile incursions, was now vulnerable to penetration by a fighter whose extended range capability permitted operations well beyond the reach of existing interceptors. This vulnerability necessitated a comprehensive reassessment of regional airspace control, early warning systems, and force projection. The American Mustang's endurance challenged the foundational assumptions of airspace denial and demanded an urgent recalibration of Japan's aerial defense doctrine. In the days following the Mustang's demonstration flights, intelligence reports from across the Pacific reflected a growing recognition of this extended range capability. The American fighter's endurance was not an isolated phenomenon but part of a broader strategic initiative aimed at achieving air superiority through sustained presence and operational flexibility. The Mustang's capacity to outlast and outmaneuver within the vast expanses of the Indo-Pacific theater marked it as a formidable asset, compelling Japan to confront the limitations of its current defensive architecture. As the implications reverberated through Japan's military command, there was a palpable sense of urgency to adapt. The Mustang's endurance had exposed critical gaps in Japan's layered defense, forcing a re-evaluation of the technological and tactical means necessary to counter this emerging threat. The extended range capability was not merely a technical advantage, it was a strategic game-changer that redefined the nature of aerial warfare in the region and set the stage for a new era of competition and innovation. Japanese air commanders convened in a somber war room, the glow of digital maps and radar displays casting stark illumination across their faces. The atmosphere was charged with a mixture of analytical rigor and mounting concern, as the recent revelations about the P-51 Mustangs' extended range capability compelled a thorough reassessment of Japan's air defense doctrine. For years, the prevailing strategy had centered on the principle of close-range interception, a doctrine meticulously crafted to leverage the strengths of Japan's stealth fighters and layered missile systems. Yet, the Mustang's endurance and operational flexibility now threatened to render these assumptions obsolete. At the core of Japan's air defense posture was reliance on aircraft such as the Mitsubishi F-3, a stealth fighter designed for rapid engagement within confined airspace. The doctrine assumed that enemy aircraft would be detected by advanced radar arrays and ground-based sensors well before they could pose a direct threat, enabling swift deployment of interceptors to neutralize incursions. This layered defense model emphasized minimizing the engagement envelope, capitalizing on stealth technology to achieve surprise and precision strikes. The Japanese military's confidence in this approach was rooted in decades of refinement and technological investment. However, the Mustang's extended range capability exposed a critical vulnerability inherent in this framework. The aircraft's ability to operate far beyond the perimeters of Japan's radar coverage introduced an element of unpredictability that challenged the efficacy of close-range interception. No longer could Japanese air commanders rely solely on early detection within a defined zone. Instead, they faced the prospect of adversaries penetrating deep into contested airspace without warning. The strategic calculus shifted from managing localized threats to countering an enemy with expansive reach and persistence. Discussions among senior officers revealed an acute awareness of these doctrinal shortcomings. The Mustang's endurance allowed it to maintain patrols and strike missions at distances that exceeded the operational radius of Japan's interceptors, effectively circumventing the layered defense network. This capability undermined the assumption that stealth fighters would have sufficient time and space to engage targets before they could complete their objectives. The Zero fighter's historic advantage in close-quarters dogfighting now appeared diminished in the face of an adversary who could dictate the terms of engagement through superior range. Moreover, the doctrine's emphasis on close-range interception had constrained the development of assets capable of sustained operations over extended distances. Japan's current fleet lacked the fuel capacity and logistical support to match the Mustang's endurance, a gap now glaringly evident. The radar and missile systems, optimized for rapid response within narrow corridors, faced difficulty adapting to the wider operational theaters necessitated by an adversary with long-range capabilities. The Japanese command recognized that these limitations compromised not only tactical responsiveness but also strategic deterrence. The Japanese military's doctrine had also prioritized stealth and electronic warfare as key components of air defense. While these technologies remained vital, the Mustang's sensor suite and avionics demonstrated a capacity to counter stealth advantages through advanced detection and situational awareness over vast distances. This technological contest introduced a new complexity, whereby electronic countermeasures and sensor fusion would need to evolve in tandem with the expanding operational ranges. The Mustang's integration of hybrid propulsion and lightweight materials further complicated the threat profile, as it combined endurance with agility and survivability. In light of these revelations, Japanese commanders began to explore doctrinal revisions that would accommodate the Mustang's extended range and operational style. This included consideration of more dispersed and flexible deployment of interceptors, enhanced coordination among radar and sensor networks, and development of new tactics emphasizing early warning and layered engagement at greater distances. The traditional model of a static air defense perimeter gave way to concepts that favored dynamic, multi-tiered responses capable of addressing threats across a broader expanse. However, the adaptation process was neither swift nor straightforward. Institutional inertia, budgetary constraints, and technological hurdles complicated efforts to overhaul Japan's air defense doctrine. The Mustang's capabilities forced a confrontation with entrenched paradigms, requiring not only hardware upgrades but also doctrinal innovation and training adjustments. Pilots accustomed to close-range dogfighting needed to assimilate new combat doctrines that emphasized endurance management, long-range tracking, and cooperative engagement strategies. The human element of this doctrinal shift was particularly pronounced among Japanese pilots. The Zero fighter, a symbol of Japan's aerial prowess, was renowned for its exceptional maneuverability and agility in close combat. Yet, the Mustang's endurance advantage revealed that aerial superiority would increasingly depend on factors beyond raw maneuverability. Pilots had to adapt to a combat environment where engagements could be prolonged, requiring sustained situational awareness and energy conservation over extended sorties. This tactical evolution challenged conventional training regimes and demanded a recalibration of pilot mindset and skills. On the strategic level, the Japanese defense establishment grappled with the broader implications of the Mustang's operational profile. The extended range capability not only threatened Japan's immediate airspace but also had ramifications for regional power dynamics. The ability of American forces to project air power across vast distances without reliance on nearby bases challenged Japan's capacity to enforce airspace denial and maintain strategic autonomy. This realization underscored the necessity of integrating doctrinal changes with broader defense policy adjustments and alliance coordination. Within this complex landscape, Japanese military planners initiated exploratory programs aimed at extending the range and sensor capabilities of future fighter aircraft. These initiatives sought to bridge the gap revealed by the Mustang's endurance, emphasizing fuel efficiency, hybrid propulsion, and advanced avionics. Concurrently, investments in unmanned aerial systems and electronic warfare platforms aimed to augment manned fighter operations, providing flexible and persistent coverage over contested regions. These efforts reflected a holistic approach to doctrinal evolution, addressing both technological and operational dimensions. The dialogue among Japanese air commanders also extended to Allied coordination and interoperability. Recognizing the challenge posed by the Mustang's capabilities, Japan sought to enhance collaborative defense measures with partner nations, integrating shared sensor networks, joint training exercises, and coordinated response protocols. This multilateral approach aimed to compensate for individual limitations and present a unified front against adversaries capable of extended-range operations. Throughout these doctrinal deliberations, the psychological impact of the Mustang's extended range remained a constant undercurrent. The realization that existing defense assumptions were vulnerable introduced a degree of urgency and introspection within Japan's air defense community. The challenge was not only to adapt technologically but to embrace a paradigm shift in how aerial threats were conceptualized and countered. The Mustang symbolized a new era of air warfare, one where endurance, flexibility, and integrated operations would define superiority. As this doctrinal evolution unfolded, Japanese military analysts documented the lessons learned from initial encounters with the Mustang. Reports highlighted the necessity of integrating long-range sensor data, expanding aerial refueling capabilities, and developing tactics that prioritized persistent surveillance and rapid force projection. These insights informed training curricula and operational planning, gradually embedding new principles into the fabric of Japan's air defense doctrine. In sum, the Mustang's extended range capability exposed the limitations of Japan's existing close-range interception doctrine, compelling a comprehensive reassessment of strategic assumptions and operational practices. This process required reconciling technological innovation with doctrinal flexibility, pilot training with evolving combat realities, and national defense policies with regional security imperatives. The encounter with the Mustang thus served as a catalyst for transformation, redefining Japan's approach to aerial defense in an era marked by rapid technological advancement and shifting strategic landscapes. The unveiling of the P-51 Mustang's capability soon revealed a series of technological breakthroughs that underpinned its unprecedented operational range and tactical flexibility. At the core of this advancement was the aircraft's hybrid propulsion system, a marvel of engineering that fused traditional turbine engines with cutting-edge electric thrust augmentation. This combination allowed for optimized fuel consumption across varying flight regimes, enhancing endurance without compromising speed or climb performance, a balance that had eluded earlier fighter designs. Engineers detailed how the hybrid system operated by dynamically adjusting power output, seamlessly transitioning between jet propulsion for high thrust requirements and electric augmentation during cruising phases. This innovation reduced fuel burn significantly during extended patrols, thereby multiplying the Mustang's effective range. The system's redundancy also enhanced reliability, allowing pilots to maintain operational capability even under adverse conditions or minor system failures. Such resilience was critical in sustaining prolonged sorties over contested airspace, where return to base was neither immediate nor guaranteed. Complementing the propulsion advances was the extensive use of lightweight composite materials throughout the Mustang's airframe. Unlike conventional alloys, these composites provided superior strength-to-weight ratios, reducing structural mass without sacrificing durability or combat survivability. The reduced airframe weight decreased drag and enhanced fuel efficiency, directly contributing to the aircraft's extended range capability. Additionally, the composites offered improved stealth characteristics, absorbing and deflecting radar signals to diminish detectability despite the Mustang's increased operational radius. Integral to the Mustang's extended reach was also its advanced fuel management system. Utilizing real-time data from onboard sensors and avionics, the system continuously optimized fuel distribution and consumption patterns during flight. Adjustments were made to engine thrust and electrical power allocation to maximize efficiency, particularly during long-range patrols or loitering phases where endurance was paramount. The fuel management algorithms incorporated environmental factors such as wind direction, temperature, and altitude, allowing the Mustang to exploit favorable conditions strategically. This precise control of resources augmented the aircraft's ability to sustain extended missions without compromising its responsiveness or combat readiness. In-flight refueling capabilities further amplified the Mustang's operational radius. Unlike previous generation fighters that depended on limited tanker support tethered to fixed operational zones, the Mustang integrated with a next-generation aerial refueling system that allowed rapid, flexible, and secure transfer of fuel during high-speed flight. This system employed automated docking procedures and advanced communication protocols, minimizing the vulnerability windows during refueling operations. The ability to refuel at distance without sacrificing combat posture extended the Mustang's mission duration beyond traditional constraints, enabling it to penetrate deep into contested territories with sustained presence. The aircraft's avionics suite represented another leap forward in situational awareness and tactical management. The Mustang was equipped with a sensor fusion system that integrated data from radar, infrared, electronic support measures, and communication networks into a coherent, real-time operational picture. Pilots could monitor threats, friendly units, and environmental variables with unparalleled clarity over vast distances. This comprehensive awareness allowed for proactive tactical decisions, evasion of enemy detection, and coordinated engagement with allied forces. The system's user interface was designed for rapid interpretation, reducing cognitive load and enhancing pilot effectiveness during prolonged missions. The sensor suite was augmented by an adaptive electronic warfare module capable of jamming enemy radar and communications while protecting the Mustang's own systems. This module dynamically adjusted its emission patterns based on threat analysis, creating a layered defense against detection and targeting. The integration of electronic attack and defense capabilities within the avionics package enabled the Mustang to maintain operational superiority even in highly contested electromagnetic environments. This technological synergy of endurance, stealth, and electronic warfare represented a formidable challenge to adversaries reliant on traditional detection and engagement methods. These technological innovations collectively constituted a leap forward in fighter jet endurance and tactical flexibility. The Mustang's design philosophy departed from the conventional trade-offs between speed, range, and firepower, achieving a synthesis that allowed it to excel across multiple domains simultaneously. The aircraft could maintain high-speed intercepts, loiter over strategic targets for extended periods, and execute precision strikes with minimal risk of early detection or fuel exhaustion. This versatility expanded the tactical options available to commanders, enabling adaptive responses to dynamic battlefield conditions. The hybrid propulsion and composite airframe also facilitated rapid maintenance and modular upgrades. The Mustang systems were designed with accessibility and adaptability in mind, allowing ground crews to replace components and integrate new technologies with minimal downtime. This forward-thinking approach ensured that the aircraft could evolve in response to emerging threats and operational requirements, sustaining its edge over rival platforms. The emphasis on maintainability underscored the strategic intent to field a fighter capable of sustained dominance, not merely one optimized for singular engagements. At the intersection of engineering innovation and tactical application, the Mustang's extended range capability imposed new demands on Japan's air defense planning. The aircraft's ability to operate at great distances required adversaries to expand radar coverage, enhance aerial refueling infrastructure, and develop countermeasures that could neutralize its endurance advantage. For Japanese analysts, These technological breakthroughs signaled the necessity for a comprehensive response encompassing both hardware development and doctrinal evolution. The Mustang's influence extended beyond technical specifications; it reshaped conceptions of air combat itself. By combining endurance with agility and electronic superiority, it challenged the traditional metrics of fighter performance that had prioritized raw speed or close-range maneuverability. The aircraft demonstrated that sustained presence and multi-domain integration could determine the outcome of aerial engagements. This realization prompted a strategic shift toward valuing flexibility and persistence as critical determinants of aerial dominance. In the broader context of Pacific aerial operations, the Mustang's technological breakthroughs heralded a new chapter in force projection. Its ability to maintain long-range escort for strategic bombers, conduct extensive reconnaissance missions, and provide close air support with endurance unmatched by previous fighters expanded the operational envelope of American air power. This capability posed a direct challenge to Japan's layered defense systems, compelling a re-evaluation of both technological investments and tactical doctrines. Japanese engineers, deeply engaged in analyzing the Mustang's innovations, recognized that replicating such a synthesis of propulsion, materials, and avionics would require significant advances in indigenous technology. The hybrid propulsion system, in particular, represented a frontier of aerospace engineering demanding extensive research and development. Similarly, the integration of sensor fusion and adaptive electronic warfare modules presented complex challenges in software architecture and hardware miniaturization. These realizations underscored the Mustang's role not only as a tactical asset but as a benchmark for future fighter development programs worldwide. As the Mustang continued its sorties, demonstrating the practical application of these technological breakthroughs, Japanese military planners accelerated efforts to incorporate similar capabilities into their next-generation platforms. Collaborative projects with allied nations sought to leverage shared expertise in propulsion, materials science, and electronic warfare. Investments in unmanned systems and autonomous flight controls aimed to extend endurance and situational awareness further, drawing inspiration from the Mustang's multi-role versatility. The aircraft's synthesis of hybrid propulsion, lightweight composites, advanced fuel management, in-flight refueling, and integrated avionics collectively constituted a paradigm shift in fighter design. This shift transcended individual technological components, embodying a systemic approach to endurance and tactical flexibility that redefined aerial combat parameters. The Mustang emerged as a symbol of innovation and strategic foresight, setting a new standard that would influence the evolution of air warfare for decades to come. During the initial joint exercises conducted over the expansive airspace of the Western Pacific, the P-51 Mustang's true tactical superiority began to manifest with startling clarity. Japanese stealth fighters, including the advanced Mitsubishi F-3, were deployed in a series of simulated engagements designed to test the limits of their capabilities against the new American adversary. What unfolded was a series of encounters that would profoundly challenge Japanese assumptions about aerial maneuverability, endurance, and strategic reach. From the outset, Japanese pilots found themselves confronted with an aircraft that defied traditional engagement parameters. The Mustang's ability to maintain high levels of performance over extended sorties was immediately apparent. While Japanese fighters had been optimized for rapid, short-duration intercepts within the confines of Japan's air defense perimeter, the Mustang demonstrated relentless persistence, sustaining combat-ready speeds and agility far beyond the expected limits. This endurance allowed the Mustang to dictate the tempo of encounters, striking or surveilling with a freedom that Japanese pilots struggled to counter. The Zero fighter's famed agility, while still formidable, was compromised by its comparatively limited fuel reserves and endurance. In extended engagements, Japanese pilots found their aircraft's performance degrading as fuel levels diminished, forcing them to disengage or risk being stranded. The Mustang, by contrast, leveraged its extended range capability to remain operationally effective throughout the duration of the exercises. This endurance advantage translated into tactical flexibility, enabling the Mustang to execute multiple attack runs, reposition rapidly, and maintain persistent pressure on Japanese formations. Japanese pilots reported a psychological impact as well, describing a sense of disorientation and frustration in attempting to anticipate the Mustang's maneuvers. The aircraft's advanced avionics and sensor fusion provided pilots with superior situational awareness, allowing them to anticipate enemy movements and exploit vulnerabilities with precision. This technological edge, combined with extended endurance, created a combat dynamic where Japanese fighters were often reacting to Mustang-initiated engagements rather than controlling the fight. The traditional advantage enjoyed by Japanese pilots in dogfighting tactics was thus eroded by the Mustang's superior operational reach and information dominance. The practical implications of the Mustang's extended patrols became evident as it operated beyond the reach of Japan's interceptors. These sorties allowed the Mustang to conduct surveillance and strike missions deep within contested airspace, effectively neutralizing Japanese attempts to enforce airspace denial. The Japanese command structure faced the stark reality that their interceptors could not reliably counter Mustang operations that extended beyond radar coverage and missile engagement zones. This forced a reconsideration of engagement protocols, as commanders sought to prevent the Mustang from exploiting gaps in the defensive network. The disparity in endurance also influenced the nature of aerial engagements. Japanese fighters, constrained by limited fuel capacity, were forced to prioritize rapid, decisive strikes, often at the expense of sustained presence. The Mustang's ability to loiter and adapt mid-mission introduced a more fluid and dynamic combat environment. This forced Japanese pilots to balance the risks of prolonged engagement against the necessity of preserving fuel for safe return, complicating tactical decision-making and reducing operational tempo. Moreover, the Mustang's integration of advanced electronic warfare capabilities further complicated Japanese interception efforts. The aircraft's adaptive jamming and stealth features disrupted Japanese radar and communication networks, degrading the effectiveness of coordinated defense measures. This electronic edge, combined with extended endurance, enabled the Mustang to penetrate defensive layers with reduced risk of detection or targeting. Japanese air commanders noted that traditional interception tactics, reliant on predictable radar guidance and coordinated missile launches, were increasingly vulnerable to such electronic countermeasures. The joint exercises highlighted the need for Japan to adapt not only technologically but tactically. Pilots and commanders alike recognized that countering the Mustang's advantages would require new engagement doctrines emphasizing cooperative tactics, multispectral sensor integration, and extended-range operations. The lessons learned underscored the limitations of relying solely on stealth and close-range interception in an environment where adversaries could sustain prolonged presence and electronic superiority. In the aftermath of these engagements, Japanese military planners initiated detailed after-action reviews, analyzing the Mustang's flight profiles, endurance metrics, and electronic warfare tactics. These assessments revealed that the Mustang's ability to combine extended range with high combat effectiveness had disrupted the established balance of aerial maneuverability. The Zero fighter's historical dominance in dogfighting was challenged not merely by superior aircraft design but by a comprehensive integration of endurance, situational awareness, and electronic warfare. The strategic consequence of the Mustang's extended patrols was a forced expansion of Japan's air defense perimeter. To counter persistent Mustang operations, Japan had to consider deploying interceptors and sensors farther afield, demanding a logistical and operational overhaul. This expansion strained existing resources and highlighted the need for enhanced aerial refueling capabilities and extended-range fighter development. The exercises acted as a catalyst, driving innovation in airborne sensor networks and rapid response protocols designed to mitigate the Mustang's endurance advantage. Japanese pilots expressed a mixture of admiration and frustration. While respecting the Mustang's technological sophistication and tactical prowess, they grappled with the challenge of adapting to an adversary whose operational philosophy prioritized endurance and information dominance. The psychological effect of realizing that their Zero fighters were outmatched in both endurance and electronic warfare capabilities was profound, prompting renewed emphasis on training programs that incorporated long-duration missions, cooperative engagement strategies, and counter-electronic warfare techniques. The joint exercises also underscored the importance of alliance coordination and interoperability. Japanese commanders recognized that countering the Mustang's advantages would require integrated sensor networks and shared situational awareness across Allied forces. Efforts to enhance real-time data sharing and joint operational planning intensified, reflecting an understanding that the Mustang's tactical innovation had implications beyond bilateral engagements. In essence, these initial encounters marked a turning point in regional aerial warfare. The Mustang's combination of extended range, endurance, and electronic warfare capabilities revealed vulnerabilities in Japanese air defense that had previously gone unconsidered. The aircraft's ability to outfly and outlast Japan's top stealth fighters disrupted established tactical doctrines and forced a comprehensive re-evaluation of engagement strategies. As the exercises concluded, it was clear that the Mustang had not only demonstrated superior performance but had also initiated a paradigm shift in the conceptualization of air superiority within the Pacific theater. The strategic implications of the P-51 Mustang's extended operational range rapidly unfolded within the highest echelons of Japan's defense establishment, forcing a profound reassessment of airspace denial strategies long considered robust. The realization that American fighters could sustain prolonged presence far beyond the reach of Japan's existing interceptors disrupted the foundational assumptions underpinning the nation's aerial defense posture. The Mustang's endurance effectively undermined the layered defense architecture, revealing critical vulnerabilities that challenged Japan's capacity to maintain sovereignty over its airspace. Japan's traditional approach to air defense revolved around creating a multi-tiered shield that combined radar detection, stealth fighters, and missile batteries to intercept hostile aircraft within a constrained perimeter. This strategy relied heavily on the predictability of engagement zones and the assumption that enemy aircraft would be detected well before penetrating strategic airspace. The Mustang's extended range shattered this paradigm by enabling operations deep within contested zones, often beyond the effective reach of Japanese radar nets and interceptor aircraft. This capability rendered static defensive perimeters obsolete, compelling Japan to contemplate a more fluid and expansive approach to airspace control. The persistent presence of Mustang fighters within the airspace challenged the effectiveness of Japan's rapid response protocols. Interceptor squadrons, designed for swift deployment against detected threats, found themselves at a disadvantage when adversaries could loiter for extended durations, conducting reconnaissance or strike missions with minimal risk of fuel exhaustion. This endurance advantage allowed American forces to seize the initiative, dictating the tempo and geography of engagements. Japanese commanders faced the daunting task of recalibrating their operational doctrines to address an adversary capable of sustained dominance. Simultaneously, the psychological impact within Japan's defense circles was pronounced. The recognition that the Mustang could outmaneuver and outlast existing defense measures fostered a sense of urgency and introspection. Military planners acknowledged that failure to adapt swiftly could lead to strategic erosion, compromising not only national security but also regional stability. This awareness galvanized efforts to enhance radar networks, improve aerial refueling capabilities, and develop countermeasures specifically tailored to offset the Mustang's endurance and electronic warfare proficiencies. Japan's scramble to upgrade sensor networks involved deploying more advanced radar systems with extended detection ranges and improved resolution. Efforts focused on integrating over-the-horizon radar capabilities, passive detection arrays, and satellite-based surveillance to close gaps exploited by the Mustang's long-range operations. This expansion aimed to restore early warning capabilities critical to intercepting extended-range threats. However, the technological complexity and financial cost of such upgrades presented significant challenges, necessitating prioritization and phased implementation. In parallel, Japan accelerated the development of aerial refueling infrastructure to extend the operational range of its own interceptor fleet. Recognizing that endurance could no longer be a limiting factor in aerial engagements, Japanese air commanders emphasized the need to sustain longer sorties through improved tanker support and in-flight refueling procedures. This logistical enhancement sought to mitigate the Mustang's advantage by enabling Japanese fighters to remain airborne and combat-ready over extended periods, closing the gap in endurance that had become a tactical liability. The strategic recalibration also encompassed electronic warfare and cyber defense initiatives aimed at countering the Mustang's sophisticated avionics and sensor fusion capabilities. Japanese military analysts identified the necessity of developing adaptive jamming techniques, resilient communication networks, and enhanced electronic countermeasures to disrupt the Mustang's situational awareness and targeting systems. These efforts were designed to level the electromagnetic playing field, reducing the effectiveness of the Mustang's electronic warfare suite that had previously granted it a decisive edge. The cumulative effect of these adaptations reflected a comprehensive response to the Mustang's challenge, underscoring the interconnectedness of technology, doctrine, and operational readiness. Japan's defense establishment recognized that endurance and range were not isolated attributes but components of a broader strategic equation encompassing detection, engagement, and sustained presence. Addressing these dimensions required synchronized advancements across multiple domains, from sensor technology and propulsion to training and alliance coordination. The psychological dimension of this strategic reckoning cannot be overstated. The awareness of vulnerability induced by the Mustang's extended range capability instilled a sense of urgency that permeated military planning and policy discussions. Japanese commanders grappled with the reality that previous air defense doctrines, while effective against known threats, were inadequate in the face of evolving aerial warfare paradigms. This cognitive shift spurred a willingness to embrace innovation and reconsider entrenched strategic assumptions, fostering a culture of adaptability within the defense community. The Mustang's challenge also influenced Japan's strategic posture beyond immediate air defense concerns. The potential for American fighters to project power with sustained endurance posed implications for regional power balances and alliance dynamics. Japan's military planners recognized that maintaining credible deterrence required not only technological parity but also interoperability with allied forces capable of complementing national capabilities. This realization prompted intensified collaboration with regional partners, joint exercises, and shared intelligence initiatives aimed at creating a cohesive response framework. Within this context, Japan's defense industry mobilized to accelerate research and development programs focused on next-generation fighters and support systems. Emphasis was placed on enhancing fuel efficiency, propulsion innovation, sensor integration, and electronic warfare capabilities. These programs sought to produce platforms capable of matching or exceeding the Mustang's endurance while incorporating lessons learned from initial encounters. The strategic imperative was clear: to restore balance by fielding aircraft that could operate with similar persistence and flexibility in contested environments. The urgency extended to tactical training and operational doctrine. Japanese pilots underwent revised curricula emphasizing long-duration missions, energy management, and cooperative engagement strategies designed to counter adversaries with superior endurance. Commanders prioritized developing tactics that leveraged networked sensors and coordinated multi-aircraft operations to mitigate the Mustang's advantages. This doctrinal evolution reflected a holistic approach, integrating technological advancements with human factors and command structures. As these strategic adaptations unfolded, Japan's defense establishment remained acutely aware of the ongoing nature of the challenge posed by the Mustang. The aircraft's extended range capability was not a static attribute but part of a broader trajectory of technological and tactical innovation. Maintaining aerial superiority required continual anticipation of emerging threats and proactive development of countermeasures. The Mustang's presence served as both a catalyst and benchmark, driving Japan's commitment to evolving its air defense posture in a rapidly changing security environment. In sum, the Mustang's endurance and operational reach disrupted Japan's airspace denial strategies, compelling a multifaceted response encompassing technological upgrades, doctrinal revisions, and alliance enhancement. The aircraft's ability to outmaneuver and outlast existing defenses reshaped regional power dynamics and underscored the imperative of adaptability in modern aerial warfare. The psychological and strategic impact of this realization resonated deeply, setting the stage for a comprehensive transformation of Japan's air defense capabilities in the face of evolving challenges. In the wake of the unsettling revelations brought about by the P-51 Mustang's extended operational range, Japan embarked on a concerted effort to adapt and overcome the strategic challenges exposed by the aircraft's capabilities. This adaptation process encompassed accelerated development of next-generation fighters, a surge in investments in unmanned aerial systems and electronic warfare technologies, and a recalibration of strategic doctrines to address the vulnerabilities laid bare by the Mustang's endurance and tactical flexibility. Foremost among Japan's response initiatives was the intensification of research and development aimed at producing fighters with enhanced range and sensor capabilities. Recognizing that endurance had become a decisive factor in aerial supremacy, Japanese aerospace engineers and military planners prioritized fuel efficiency, propulsion innovation, and lightweight structural materials. The objective was clear: to field aircraft capable of sustained operations that could match or surpass the Mustang's extended range capability. These next-generation platforms were envisioned to integrate hybrid propulsion systems inspired by the Mustang's design philosophy, marrying speed with longevity in a manner that preserved maneuverability without compromising endurance. Simultaneously, Japan intensified investments in unmanned aerial vehicles, UAVs, and drone swarms, technologies that promised to augment manned fighter operations and extend surveillance and strike capabilities over vast distances. These unmanned systems offered the advantage of persistent presence without the physical limitations of human pilots, potentially providing continuous coverage and rapid response options against extended-range adversaries. The development of autonomous and semi-autonomous flight controls, combined with sophisticated sensor packages, sought to create a layered defense network capable of countering the Mustang's sustained patrols and electronic warfare tactics. Electronic warfare emerged as a critical domain in Japan's adaptation efforts. The Mustang's advanced avionics and adaptive jamming capabilities had demonstrated a formidable edge in disrupting traditional detection and targeting systems. In response, Japanese military research focused on developing resilient electronic countermeasures, including advanced signal processing algorithms, cyber defense mechanisms, and adaptive jamming techniques designed to degrade the Mustang's situational awareness. These efforts aimed to restore parity in the electromagnetic spectrum, ensuring that Japanese forces could maintain reliable communication and sensor functionality even in contested environments saturated with electronic interference. The imperative to address the Mustang's endurance advantage also drove enhancements in logistical support and aerial refueling infrastructure. Japan expanded its fleet of tanker aircraft and refined in-flight refueling procedures to support longer sorties by its interceptor squadrons. This logistical evolution was essential to extend the operational radius of Japan's fighters, enabling them to maintain combat readiness over greater distances and durations. The integration of refueling capabilities with next-generation fighters was a focal point, seeking to ensure seamless endurance that could rival the Mustang's sustained presence. Strategic doctrines underwent significant revision to incorporate lessons learned from encounters with the Mustang. Traditional models emphasizing close-range interception and static air defense perimeters gave way to concepts advocating dynamic, multi-layered engagements across expansive theaters. Japanese commanders emphasized cooperative tactics, networked sensor fusion, and multi-axis operations designed to counter adversaries capable of operating beyond previous range constraints. Training programs were overhauled to prepare pilots for extended missions requiring energy management, situational awareness, and coordinated team tactics in complex electronic warfare environments. In alignment with these doctrinal shifts, Japan pursued enhanced collaboration with Allied forces, recognizing that countering the Mustang's capabilities necessitated collective defense measures. Joint exercises, intelligence sharing, and interoperability initiatives were intensified to create a unified front capable of responding rapidly and effectively to extended-range threats. These partnerships facilitated the integration of sensor networks and coordinated response protocols, expanding situational awareness and force projection beyond national boundaries. The Mustang's presence thus catalyzed broader efforts to strengthen regional security architectures through alliance cohesion. The adaptation process also involved a cultural shift within Japan's defense establishment. The psychological impact of confronting a technologically superior adversary fostered a renewed commitment to innovation and flexibility. Military leadership championed an environment encouraging rapid experimentation, cross-domain integration, and agile decision-making. This cultural transformation aimed to accelerate the assimilation of new technologies and doctrines, ensuring that Japan's aerial defense posture could evolve in step with emerging threats. Investments extended beyond hardware and tactics to encompass research in artificial intelligence, machine learning, and data analytics. These technologies were viewed as essential for managing the complexity introduced by extended-range engagements and electronic warfare. AI-driven systems promised enhanced threat detection, predictive maintenance, and real-time decision support, empowering pilots and commanders to navigate the increasingly intricate battle space shaped by the Mustang's influence. The cumulative effect of these multifaceted adaptation efforts was a comprehensive transformation of Japan's air defense capabilities. By integrating advances in propulsion, unmanned systems, electronic warfare, logistics, and doctrine, Japan sought to mitigate the Mustang's endurance advantage and restore strategic balance. This transformation was not merely reactive but proactive, positioning Japan to contend with future aerial warfare challenges anticipated to emphasize endurance, flexibility, and multi-domain integration. Throughout this process, Japanese pilots remained at the forefront of adaptation. Training programs emphasized extended sortie durations, electronic countermeasure tactics, and cooperative engagement strategies designed to offset the Mustang's persistent presence. Pilots were conditioned to operate within networked environments, leveraging shared situational awareness and coordinated maneuvers to counter adversaries with superior endurance. This human factor adaptation was critical to translating technological advances into operational effectiveness. Japan's defense industry, galvanized by the Mustang's challenge, accelerated innovation cycles and fostered partnerships with academic institutions and private sector entities. This ecosystem aimed to cultivate cutting-edge technologies and expedite their integration into operational platforms. The Mustang thus served as a benchmark and motivator, driving Japan's commitment to maintaining aerial superiority through continuous technological and doctrinal evolution. In essence, Japan's response to the Mustang's extended range capability embodied a holistic approach that recognized the intertwined nature of technology, strategy, and human factors in modern aerial warfare. The accelerated development of next-generation fighters, investments in unmanned and electronic warfare systems, and strategic collaborations reflected a determined effort to adapt rapidly and decisively. This multifaceted adaptation not only addressed immediate vulnerabilities but also laid the groundwork for sustained air defense resilience in an era defined by rapid technological advancement and shifting strategic landscapes. The introduction of the P-51 Mustangs' extended range capability reverberated far beyond the borders of Japan, capturing the attention and concern of neighboring countries throughout the Indo-Pacific region. As reports of the Mustang's endurance and tactical flexibility permeated defense circles, regional military planners grappled with the implications of an aircraft that challenged traditional air power paradigms. The Mustang's presence catalyzed a wave of strategic recalculations and military modernization efforts, signaling a shift towards an arms race centered on endurance, electronic warfare, and force projection. Neighboring nations, observing the Mustang's demonstrated ability to operate persistently over vast distances, recognized that their own air defense architectures faced similar vulnerabilities to those exposed within Japan. The aircraft's extended range capability underscored the limitations of static defense perimeters and conventional interception doctrines that had long guided regional air power strategies. This realization prompted a reassessment of defense priorities, with a pronounced emphasis on extending sensor coverage, enhancing aerial refueling capabilities, and developing next-generation fighters capable of sustained operations. The Mustang's endurance advantage also heightened concerns about the balance of power in contested maritime domains and airspace corridors critical to regional security. Countries with territorial disputes or strategic interests in the South China Sea, East China Sea, and broader Pacific theater viewed the Mustang as a force multiplier for American influence and rapid response. This dynamic intensified efforts to field aircraft and systems that could counter extended range operations, driving investments in stealth technology, long-range missiles, and integrated electronic warfare suites designed to disrupt adversary sensor networks. The regional arms race precipitated by the Mustang's capabilities was not merely a competition of platforms but a contest of technological innovation and doctrinal adaptation. Defense establishments across the Indo-Pacific accelerated research in hybrid propulsion systems, lightweight composite materials, and advanced avionics, technologies exemplified by the Mustang's design. Investments in unmanned aerial systems and swarm tactics gained prominence as nations sought to offset disadvantages in manned fighter endurance and expand surveillance and strike capabilities across expansive maritime domains. Electronic warfare emerged as a focal point in this regional military shift. The Mustang's sophisticated sensor fusion and adaptive jamming capabilities illustrated the decisive role of electromagnetic dominance in modern aerial combat. Regional powers prioritized the development of resilient communication networks, cyber defense measures, and electronic countermeasures to maintain operational effectiveness in contested electromagnetic environments. This emphasis reflected an understanding that endurance alone was insufficient without the ability to operate securely within complex and contested battle spaces. Japan's experience with the Mustang served as a catalyst and template for these broader regional transformations. The lessons learned from initial encounters influenced defense dialogues and cooperative initiatives among allied and partner nations. Joint exercises incorporating extended-range engagement scenarios, electronic warfare simulations, and coordinated air defense operations became increasingly common, fostering interoperability and shared situational awareness. These collaborative efforts aim to create a cohesive regional response capable of mitigating the challenges posed by aircraft with extended operational reach. The Mustang's emergence also influenced strategic discussions on force projection and deterrence. Nations sought to enhance their ability to project air power rapidly and persistently across contested zones, recognizing that endurance and flexibility were critical to maintaining influence in a multipolar security environment. This strategic recalibration extended to the development of forward operating bases, aerial refueling networks, and rapid deployment forces capable of sustaining prolonged operations far from home territories. In this evolving context, the Mustang's extended range capability became a benchmark for future fighter development programs. Aerospace industries across the region examined the aircraft's integration of hybrid propulsion, fuel management systems, and advanced avionics as a model for achieving operational endurance without sacrificing combat effectiveness. This benchmarking spurred innovation cycles, driving the pursuit of fighters that combine speed, stealth, and persistence in new and unprecedented configurations. The regional military response was not without challenges. Technological barriers, budgetary constraints, and the complexity of integrating new systems into existing defense architectures necessitated careful prioritization and phased modernization efforts. Nonetheless, the Mustang's influence accelerated the pace of military transformation, compelling rapid adaptation to a security environment increasingly defined by extended-range aerial combat and multi-domain integration. Amid these shifts, the psychological impact of the Mustang's capabilities resonated within regional defense communities. The recognition that traditional air defense strategies were vulnerable to persistent, long-range incursions fostered a sense of urgency and strategic re-evaluation. Military planners and policymakers grappled with the implications for national sovereignty, crisis response, and alliance commitments. This heightened awareness reinforced the imperative of continuous innovation and collaborative security frameworks. The Mustang's extended range also influenced broader discussions on the future of air combat, emphasizing the importance of endurance, networked operations, and electronic warfare dominance. These themes permeated military academies, defense think tanks, and strategic forums, shaping the intellectual discourse surrounding air power and force projection in the Indo-Pacific. The aircraft's operational profile challenged conventional wisdom and inspired a re-evaluation of how air superiority would be achieved and maintained in the coming decades. In sum, the Mustang's arrival in the Indo-Pacific theater precipitated a regional arms race centered on endurance and electronic warfare capabilities, reshaping military priorities and strategic calculations. Its influence extended beyond immediate operational encounters to inform broader defense modernization, alliance cooperation, and doctrinal evolution. The Mustang emerged not only as a technological marvel but as a transformative force shaping the future trajectory of aerial warfare and regional security dynamics. The P-51 Mustang's technological breakthroughs and operational successes established new benchmarks that would reverberate throughout modern aerial warfare, fundamentally altering the standards by which fighter aircraft were designed and employed. Its unprecedented combination of extended range, tactical flexibility, and integrated multi-domain capability set a precedent that influenced not only immediate adversaries but also the global trajectory of air combat development. At the heart of the Mustang's legacy was its demonstration that endurance need not come at the expense of speed, maneuverability, or firepower. By integrating a hybrid propulsion system and employing lightweight composite materials, the Mustang achieved operational radii that surpassed previous generations without sacrificing combat performance. This synthesis challenged long-held assumptions about the trade-offs inherent in fighter design and compelled aerospace engineers worldwide to reconsider the balance between range and agility. The Mustang's avionics and sensor fusion technology further redefined expectations for situational awareness in aerial engagements. By merging radar, infrared, electronic support measures, and communications data into a unified operational picture, the aircraft empowered pilots with unprecedented battlefield insight. This capability not only enhanced decision-making but also facilitated coordinated operations across multiple platforms and domains, exemplifying the shift toward network-centric warfare that would dominate future conflicts. Other nations, observing the Mustang's capabilities and strategic impact, embarked on ambitious programs to replicate or surpass its innovations. Research initiatives focusing on hybrid propulsion sought to harness similar efficiencies, while materials science advanced to produce even lighter and more resilient airframes. Efforts to develop sensor fusion systems and adaptive electronic warfare suites accelerated, reflecting an understanding that endurance, stealth, and electronic dominance were inseparable pillars of modern air superiority. The Mustang's influence extended beyond manned fighters to the design and deployment of unmanned aerial systems and autonomous platforms. Its emphasis on sustained presence and integrated electronic warfare capabilities informed the development of drones capable of long-endurance surveillance, precision strike, and electronic attack missions. This evolution marked a convergence of manned and unmanned systems within a holistic approach to air power, emphasizing persistence and multi-domain integration. Doctrinally, the Mustang's breakthroughs prompted a re-evaluation of engagement strategies. Air forces worldwide shifted focus toward concepts prioritizing long-range dominance, rapid deployment, and sustained multi-role performance. The aircraft's ability to conduct extended patrols, provide long-range escort, and adapt to dynamic combat environments underscored the necessity of flexible tactics and agile command structures capable of maximizing endurance advantages. Training paradigms evolved in response to these operational realities. Pilots were conditioned to manage energy and situational awareness over prolonged sorties, emphasizing cooperative engagement and networked operations. The Mustang's example highlighted the importance of integrating human factors with technological capabilities, ensuring that endurance translated into effective combat power rather than mere operational duration. The Mustang's legacy also shaped the evolution of Allied defense collaborations. Shared experiences and lessons learned from encounters with the aircraft fostered enhanced interoperability and joint development programs. These initiatives aim to produce platforms and systems capable of operating seamlessly across coalition forces, leveraging endurance and information dominance to achieve collective air superiority. On a strategic level, the Mustang's impact underscored the critical importance of technological innovation in maintaining aerial dominance amid rapidly evolving threat landscapes. Its breakthroughs accelerated the pace of aerospace research and development, compelling nations to prioritize adaptability and forward-looking design philosophies. The aircraft became emblematic of the continuous cycle of innovation necessary to anticipate and counter emerging challenges in air warfare. Moreover, the Mustang influenced the integration of multi-domain operations, linking air, space, cyber, and electronic warfare capabilities into cohesive combat strategies. Its advanced avionics and electronic warfare modules demonstrated the effectiveness of such integration, setting a standard for future platforms to operate within interconnected battle spaces. This holistic approach to air superiority marked a departure from isolated platform capabilities toward comprehensive operational ecosystems. The aircraft's enduring influence extended into the shaping of future fighter jet generations. Design philosophies increasingly reflected the Mustang's balance of endurance, agility, and electronic sophistication. Concepts such as modularity, maintainability, and upgradability were incorporated to ensure longevity and adaptability in a fast-changing technological environment. The Mustang's legacy thus informed not only immediate successors but also long-term aerospace development trajectories. In the realm of unmanned systems, the Mustang's emphasis on long-range, multi-role performance inspired advances in autonomous endurance and cooperative swarm tactics. These developments aim to replicate the Mustang's persistence and tactical flexibility without the limitations imposed by human physiology. The integration of artificial intelligence and machine learning within these systems echoed the Mustang's pioneering approach to sensor fusion and electronic warfare. The Mustang's breakthroughs also influenced strategic thinking regarding force projection and rapid response. Its capacity for extended-range escort and persistent surveillance demonstrated the advantages of maintaining a continuous presence in contested theaters. This capability reshaped military planning, emphasizing the need for rapid deployment forces equipped with long-endurance platforms capable of sustained operations far from home bases. In summation, the P-51 Mustang's technological and tactical innovations set new standards for range, flexibility, and multi-role performance in aerial warfare. Its influence permeated aircraft design, operational doctrine, training, and strategic planning on a global scale. By redefining endurance as a cornerstone of air superiority and integrating advanced avionics and electronic warfare capabilities, the Mustang established a legacy that continues to shape the evolution of air combat and aerospace innovation worldwide. The saga of the P-51 Mustang's emergence into the Indo-Pacific theater stands as a profound testament to the transformative power of technological innovation in redefining the contours of modern aerial warfare. Its impressive extended-range capability did more than challenge Japan's established defense assumptions. It compelled a rapid and comprehensive adaptation across multiple dimensions of military planning, technology, and strategy. The Mustang embodied a new paradigm where endurance, flexibility, and integrated systems became paramount, reshaping the very essence of air combat in the 21st century. Japan's initial confidence, rooted in doctrines emphasizing close-range interception and layered defense, gave way to a sober acknowledgement of vulnerabilities exposed by the Mustang's operational endurance. This realization initiated a cascade of responses: accelerated development of next-generation fighters, enhanced sensor networks, expanded aerial refueling capabilities, and intensified electronic warfare efforts, all aimed at countering a platform that had redefined the operational envelope. The Mustang's presence illuminated the imperative for continuous innovation, underscoring that technological superiority was neither static nor guaranteed but demanded persistent investment and adaptation. The narrative of the Mustang's impact is also a narrative of psychological and strategic reckoning. The Japanese air commanders confronted the unsettling truth that their Zero fighters, once symbols of aerial dominance, faced an adversary capable of outmaneuvering and outlasting them across vast distances. This confrontation fostered a mindset shift within Japan's defense establishment, from complacency in established paradigms to urgency in embracing change. It highlighted the dynamic nature of air warfare, where yesterday's advantages could rapidly erode in the face of novel technologies and evolving tactics. Strategically, the Mustang's extended range capability disrupted regional power balances, compelling Japan and its neighbors to reassess airspace control, force projection, and alliance coordination. The aircraft's ability to operate persistently within contested zones without reliance on proximate bases challenged traditional concepts of territorial defense and deterrence. This shift underscored the interconnectedness of technological innovation and geopolitical strategy, illustrating how advancements in a single platform could ripple through regional security architectures. The Mustang's influence extended beyond immediate tactical and operational considerations, inspiring a broader re-evaluation of air combat's future trajectory. Its integration of hybrid propulsion, lightweight composites, advanced avionics, and electronic warfare modules exemplified a systemic approach that transcended incremental improvements. This holistic innovation set a new standard for fighter design and operational doctrine, emphasizing endurance and multi-domain integration as critical determinants of superiority. In reflecting upon the Mustang's legacy, one recognizes its role as both a catalyst and symbol of transformation. It catalyzed accelerated technological development, doctrinal evolution, and strategic adaptation across Japan and the wider region. As a symbol, it represented the relentless pursuit of innovation and the enduring imperative to anticipate and counter emerging threats in an ever-changing battle space. The Mustang's story encapsulates the essence of modern aerial warfare, a continuous contest of ingenuity, resilience, and adaptation. Ultimately, the P-51 Mustang's extended range capability embodies a lesson in the evolving nature of military power. Technological breakthroughs can swiftly alter the strategic landscape, challenging established assumptions and compelling rapid responses. Maintaining aerial superiority requires not only cutting-edge platforms but also the agility to integrate new capabilities, revise doctrines, and cultivate adaptive mindsets. The Mustang's impact serves as a powerful reminder that in the high-stakes arena of air combat, innovation is both the sword and shield that shapes the future of warfare.